DAOS on Aurora, speeds and feeds and use cases. So I thought I would start with a quick high-level introduction. I won't get too much into the details here, but explaining why DAOS, why maybe from a high level is different from anything you have seen so far, Lustre and so on. So first of all, it's open source, like Lustre. We have a foundation that was created a few years ago now, including Google, including HPE, including ALCF as well, and other players. So we develop it as an open source project, right? The whole code is available on GitHub, and it has an interesting layering, which is a bit different than maybe what we are used to. It doesn't present just a POSIX interface, just files and directory. The native interface isn't POSIX. We do support files, directory, and so on, but we build everything on top of a distributed key value store, which is what this libDAOS library provide. Those key value store are a bit complex, right? They are just not a single value. The value can also be an array, right? So we design it in a way where you can represent structured data like array natively on top of this key value store, as well as unstructured data, right? By using more like key value store type of semantics. So we came up with this hybrid data structure that we call key value array store, right? That's a new term we came up with. And that's really trying to merge the best of both worlds, structured and unstructured. And obviously, not every application can directly use this nice interface, and we wanted to integrate it with more standard interface. Obviously, POSIX files and directory. So we have implemented a parallel file system on top of it, which is what this files box is. We also have blocks. Then we integrated further with HPC-IO middleware, as you will see later with MPI-IO and others, and also obviously AI framework, right, with PyTorch and so on. And we also have native support with Hadoop file system connector. So the idea was to create a new baseline API that can be integrated with different middleware, still supporting all the legacy interface with file and directory, but trying to expand on it by providing alternative interface that user can use as they get familiar with the storage systems. Another major difference that DAOS is end-to-end in user space. Lustre, that you may be familiar with, is end-to-end in kernel, right? So the client is in the kernel, the server is in the kernel, and DAOS is the opposite. Everything is done in user space, and you will see what are the pros and benefits later in the presentation. We rely on data protection over the network, right? So obviously you want to be able to survive failure of a storage node. And we do data protection, erasure code, and replication over the network. So there is no redundancy inside one node. It's always over the network. So obviously when one node fails, we have this collective process across all the storage nodes trying to restore the redundancy of the data to make sure that your data is safe, right, and continue to be available during the failure. The baseline key value store, if you are ever interested to use it, has some interesting property. It supports distributed transaction, and it's version based and multi-version concurrency control. So we try to use a lot of literature from the databases and try to implement it inside this baseline key value store. High performance is really developed to have very big IOQ and depths to support a lot of IOPS and high bandwidth, right? And we also build on top of user space communication middleware like libfabric that you might be familiar with. On Aurora, we use Slingshot, so we use libfabric mostly, but on other systems like LRZ, we are using Mellanox, and we are built on top of UCX, right, which is another communication layer developed by open source, but mostly developed by NVIDIA. So we wanted to use those user space communication layer to be able to provide very low latency and leverage all the work that has been done on MPI and so on to really grant low latency. So typically, on Aurora, I haven't measured it recently, but a read latency is below 30 microseconds, right? While other storage systems are more in the ballpark of below a millisecond, right, for a 4K read. Any questions about this high-level introduction? Okay, so Aurora. We have been working closely with Argonne for quite a while now on this DAOS system. And one thing that is important is that it's directly connected to the Slingshot fabric, right? So DAOS use CXI provider in the same way that you have MPI probably using CXI provider in the fabric directly. DAOS is built on top of the same provider, right? Using the user space communication layer. We have 1024 storage node connected to the Slingshot fabric. And the name of those nodes are not accessible to end users, but Gordon and team know them pretty well. They are called Aurora, DAOS, and then a number. Each storage node has two Slingshot interfaces and two sockets, and basically we run one engine, DAOS engine, which is what manages requests over the network and manage your IO, one engine per socket, right? So we have two engines per node. The raw capacity of one storage node is 244 terabyte per node. Doesn't include the data protection that you have to add on top of that. And this baseline storage node, these baseline building blocks, can get us roughly 40 gigabyte per second for read and write. Right, so that's pretty high, and times 1024. If you don't add data protection and just look at the raw bandwidth, you see that we have quite a lot of bandwidth available directly on the Slingshot fabric. 64 rack, and overall the system with data protection and when we're at full speed, a single DAO system covering everything. We will have with a ratio code 220 petabyte and more than 31 terabyte per second when we are at full capacity. This is to compare with the other storage system currently available on Aurora, which is Flare Luster, which cap at 600 gigabyte per second. So you can see there is a significant gap here, and this is why I think it's important to really understand how to use DAOs, because it's going to be critical, in my opinion, for going forward for applications. We are connected to the fabric through 8 Dragonfly IO group, right? You can see at the top here, you have all the compute group, and you have 8 IO group, which include the 8 rack per group, and overall those 64 rack, right, across the 8 group. There is adaptive routing enabled. Correct me if I'm wrong, Gordon and teams. So we have the compute group can bounce through the other compute group to access the IO group, but obviously the IO group, there is no adaptive routing between the IO group to go back to the compute group. This is why when we designed the system, we actually decided to have more links between the IO group here. You see in purple, we have 24 links, whereas in general, you have 2 links per arc, right? And the reason why we need more bandwidth between the IO group is that we don't have adaptive routing to be able to go back to the compute group for cross IO group traffic. And this cross IO group traffic is required for data protection, right? When something fails, as I explained, we do this collective operation trying to restore the data redundancy, and the data is sent between the storage node, right? So this is why we have more links here. Today, the system is split into different, this pool of 1024 nodes is split under several systems, right? One used by HPE and some other used by Argonne. And today, the main production system is DAOS user. There is also another one, DAOS per, for the same size, include a eighth of the capacity and bandwidth with 128 storage node. And this capacity is and bandwidth is going to grow over time, right? More nodes are going to be added, working between HPE and ELCF to have more capacity and more bandwidth available to the end user. But there is quite a lot already available there. As you can see, there was a hack run done by Kaushik here. He ran it on Flare and on Luster, and he shared it into his slide last week, I think. Was able to get close to the peak performance of DAOS, being above 5 terabyte per second for checkpoint. And if you ran it over Luster, was getting good result for the capacity of the Luster system, which was 600 gigabyte per second. So, and this bar here is going to scale by 8x eventually when we are at full speed. Any questions? Okay, so wanted to quickly have a discussion on the DAOS use cases, why we think DAOS is good for. So obviously, you have this super high bandwidth and large capacity and integration with HPC framework, so it's particularly suited for checkpoint restart, but also for everything related to what's sometimes called irregular accesses, so more out of core data. So input file, output file, any other file not related to checkpoint restart, I think makes sense to store them on DAOs because it provides very high IOPS and very high concurrency, right? And we obviously support natively POSIX, as I said, and you will see later how, but also all those HPC framework. But we also have integration with all those analytics framework. I mentioned Apache ecosystem, which is integrated with Spark. So we have all the connectors there that are available that might allow you to provide better performance with analytics application that can be discussed as well. And as you will see more in the advanced middleware, you can always use PyTorch and so on with the traditional data loader. It works well with the interception library and so on. So without using anything special. But you can also integrate it tighter by using the PyTorch data loader that we have developed and hopefully get more performance from your AI pipeline. So I was asked to provide quickly, do the first few slides, an example on how to use DAOs. So I will quickly glance through it to show that it's not that difficult, at least to get the baseline configuration set up. And then for the rest of this presentation, I will explain what each of these mean. So first of all, on Aurora, when you are on the UAN, you need to run those commands. So module use soft module file and then module load DAOs just to load the DAOS environment, right? The connect to the agent and also having all the library and utility into your path. Then normally there is a process that you went through to get an allocation of on the DAOS system, right? So DAOS has the notion of pools that I will explain later. So assuming that we have gone through this internal process to LCF to get a pool allocated, a space reservation allocated to your project, you were already granted access to it. So there was ACL set up to allow you as a user to access it. So you just have to run DAOS pool list and you should only see the pool that you have access to. If currently there are like 80 pools, so if I run myself DAOS pool list, since I was granted access to other pool, I see all of them. But as a user, you will only see you only see what you have access to. So if you don't recall the name of your pool, that's a good way to see it. In this case, I use HPE test. That's the name of my pool that was allocated to me. And I can just create a namespace, right? So by definition, by default, you have nothing. So you need to create a namespace, a POSIX namespace, where you will store your data set. So it's not like a file or a directory. It's really like a namespace with subfile and subdirectory that can be pretty big and include billions or trillions of files that you can create. And there is this command line that you can use to create a container inside the pool. And obviously you need to rename, to replace HPE test with the name of your pool. And for the container name, you can pick whatever you want, right? And we will explain later what those parameters are for. And eventually we will integrate them as default and you don't need to run them anymore. Then you can create a directory that will be your mount point and then mount it, right? So you can just use the start diffuse on the UAN. Here, this is the mount point where you want the POSIX container, POSIX namespace to be mounted. The name of the pool, which is the same as here, and then the name of the container, and then it's mounted under the DAOS directory. And it can be something with the TMP or wherever you want. And then you can CD under it, create files, copy things from anywhere you want, execute binary, and this is it. And then when you are done, you can unmount it. So you have this ability to be able to mount it and unmount it yourself because this is a user space file system, right? Using Fuse. Any questions? Okay. So the DAOS concept, so I mentioned pools, container, maybe that was a bit difficult to understand for now, so I will get now to the next level of details. So DAOS has basically three high-level concepts, which has encapsulated one into each other, right? Objects are inside the container, and containers are inside the pool. At the top, you have the pool, which is basically a distributed reservation, space reservation across multiple storage nodes for your project. right? It's the space that was allocated to your project. It's not shared with other project. You ask for a specific amount of space, and administrator will grant you this space. If someone else fill up their pool, your pool is still it still has free space, right? It's completely, you are isolated from a space standpoint from other project. And it's a kind of a tenant, right? We also have different ACL, access control lists, to be able to grant access to the pool to different users. Normally, a pool doesn't necessarily to be spread across all the nodes, but for Aurora, it was decided that all pools are always distributed across all the nodes. But DAOS has this capability to limit a pool to a specific set of storage nodes, but that wasn't the case on Aurora. So it means that for every pool, you basically are distributed across all the nodes, so you normally have the maximum bandwidth and maximum IOPS, right? Which is shared obviously across the users, but you are not restricted the way the system is configured currently. We expect to have an order of hundreds of pools in a system, right? So when you have this pool for your project that is represented here, then you can create data sets, right? And we call them container. I wish we call them dataset instead of container, because container is a bit confusing lately, right, with Linux container. But it was a bit too much into the code and spread everywhere in the documentation. Maybe one day we will change it, but today we call them container, but you should really understand dataset. And you can create different containers, dataset inside this pool that will share the space, right? There is no space reservation per container. They will all share the space allocated for the pool. We usually say that the pool are fat provision and the container are thin provision, right? So a container, you can see them as a bucket for those who are familiar as well with S3 and so on. It's basically a consistent unit of file that you want to be together that represent a data set inside your app, right? Like a checkpoint, or all your checkpoint can be a data set, all your input file. If you usually have different type of data set, you will store them in different container. But we are typically looking for tens or hundreds of container inside the pool, but not more than that. So please don't create one container per file. That's definitely not the use case, right? And you can have in a container, like as I said, trillions of files. When we did IO 500, we got, I don't remember, 40 billion file into one container, right? So it scales pretty well with the number of file and directory there. And inside this container, you create object. We'll go quickly there because this object are the key value store I mentioned before, but effectively you can see them as files in directory, right? An object can be a file or a directory, even if under the hood there is another API that allows you to access as a key value store, basically. So let's get into pool. I explain here. So I have an example here with 3 pools. They can be, in this case, distributed across a subset of the engine, more or less engine. Then they can have different capacity and different level of performance, right? Obviously, the wider you are spread across more node, the more parallelism and bandwidth you have over the network across the storage node, and the more performance you have, right? But as I said, in the case of Aurora, all pools are distributed everywhere, so you have the maximum performance. Not the same capacity, but the maximum performance for each pool. So a few examples. Find my pool. I covered that before. So you load module use soft module, module load DAOS, and then you run DAOS pool list. If you see nothing, it means that nobody has given you access, granting you access to a pool, and you need to go through an internal process to get added to an existing project or to get a new pool allocated for your project. Then when you have a pool, you can, for instance, want to know how full it is, right? You can run DAOS pool query. It's a bit difficult to parse, and we definitely need to improve it. But what is important here is the free space and the total size, right? This is the total size of your pool, 4.7 terabyte, and this is the free space, right? DAOS has this notion of space for metadata, which is basically storage tier 0, and space for data. But to some extent, you can disregard that and only look at the NVMe space until as long as you have space there. When it's full, then you might get enough space before your NVMe space is full. But I think the main one is really on the NVMe side. Container, I mentioned you can create container dataset. So really the idea is like aggregate together a set of files that should be managed as a single unit. If you can delete a container with one command line. So the idea is like really you put all those files that are consistent and current that belongs to the same dataset inside a container. And then you can manage it as one unit and you can move them to a different container. You can delete them in one go by DAOS const delete, right? You don't need to do rm-rf across the tree, scanning the file and deleting them. That can be an heavyweight process. So really, this is really why we implemented this concept, right? This is the basic unit of storage, right? We support snapshot. So when you do snapshot, you do snapshot at the container level, right? And the user can create their own snapshot. And even if 99% of you and other users will be using POSIX namespace, creating a hierarchical files and directory, there are those other use cases that we will present later where you can create a data set that is non-POSIX that will be integrated with Python, a key value store, and so on. DAOS has this capability. I think I cover everything into this slide. So let's look in practice what it looks like. So once you have the pool, we can list all container, all data sets existing in a pool. So DAOS can't list then the name of the pool. I have only one existing container in my pool that someone else created, which is called my POSIX count, right? And this is just a UUID that we allocate to the container, right? You can disregard it. You can always use just the label. And I want to create a new POSIX container for me to play with. So I do DAOS container create. I specify the name of my pool and the name of my container. And those stuff, we will see later what that means. They should really be default, as I said. So it means it was created. This was the UID allocated to my container, and it repeat the name, and it tells me it's a POSIX one. Then I can list again, and now, oops, I see my container. Nice, it is it is reporting into my pool. I can query the same way I query the pool for space information. I can query my container, and we will show information there. So there is number of handle, how many times currently it is open by how many client. Some information about the property, and also we have last time it was opened, right? It was mounted, and the last time it was closed, right? We should really change that just to put the timestamp here because nobody can decode the exa here, but here you have the time where it was last open and closed. And we will be adding over time as we grow the house more and more container properties, container information. So container property, they are more like intrinsic parameters of the container when you created it, like the access control list, the redundancy level, the owner, and so on. You probably don't need to check anything there, but for the sake of completeness, I presented here. The main thing that you want to see maybe is the label, the type, and then the ACL. If you ever wanted to share your container with someone else, then you might have to add some ACL, right? And then we can give you some example about how to add an ACL for a specific user. You can store metadata on the container. So for instance, if you want to label something for the container, so it's a data set, you want to add some description or some metadata associated with the set of file that is in there, we support specific metadata that you can set on the container. So you can list all the user metadata, like extended attribute that you can put on the container. By default, I had none, right? And then I added a new DAOS const set attr, here my pool name, my container name. This is the name of the new attribute you want to create. I call it description, right? Wasn't very imaginative at that time. And I put dataset including pressure and temperature, right, as a description. And then when you look at container list attr with -v, it means I want not to just to list the attribute on the container. I want to see the value of the attribute, right? So I have the value there. You also have DAOS const get attr if you just want to get a single value, right? And then you can also delete those description, and then when you list, delete the attribute, then it's not there, right? So I'm sure you can consider many metadata that you don't want to store maybe inside the container itself that might be suitable to put into those attributes. So can the container dataset be moved from one DAOS cluster to another DAOS cluster, for example, import-export scenario? So you can move it inside the same DAOS system, right? So we have a way to do DAOS copy, right? So you can copy with a DAOS utility or with a parallel utility in PI5 utils a container from one pool to another pool, right? But I assume your question is you want to move it to a storage system that is non-DAOS, right? Then in this case, the way to do copy for POSIX is to copy it at the POSIX level, right? So we will scan the content of the POSIX directory and copy it to Lustre, for instance, right? And at that point, it's not going to be, when it's stored on Lustre, it's not going to be a container or the data set anymore. It's just going to be a directory that was copied there. Does it answer your questions? Alex, meeting? Feel free to unmute if you have further questions.
He said yes.
Okay, good.
If I could ask,
Sure.
is it possible if I'm just moving something offline temporarily, but I want to move it back onto DAOS, can you put some sort of raw representation of the container onto a file system, POSIX
Yeah.
file?
So we have a tool that allow you to serialize a container at the key value store level as well, right? So you can do the copy at the POSIX, and then the result of the copy on Lustre is going to be the file as you interact with it, right? But there is also a low-level copy where basically you can we call it container serialization. When you take a container or dataset in DAOS, you serialize it to a third-party file system. And then later you can deserialize it back to DAOS. But in this case, the format on the external file system is not human readable, right? It's not POSIX in this case.
Would it be faster to do that than to go through the POSIX layer and copy it?
I don't know about speed. Mohammed, you have any thought on whether which path is faster? I don't know actually.
Sorry, can you ask the question again?
Whether is it faster to copy at the POSIX level with DCP or compared to doing the DAO serialization stuff to SGF5?
It's definitely faster to copy with DCP if you just the POSIX, because DCP is a parallel tool, especially on Aurora. You can just do an MPI exec with several nodes, several processes that will speed up the copy way more significantly than doing the DAOS tool, which is a serial tool, basically. So if the question is about speed, definitely using the MPI file util parallel copy tools, those are much faster.
We haven't done DAOS realization into the MPI file utils. I thought we did. No, we didn't.
I don't.
Okay.
I have to.
Maybe a question for offline. Yeah. So
yeah,
at the POSIX level is going to be faster. Yeah, is the answer.
Thank you.
Yeah, so Johann, to answer that, we have, but it's still sort of in progress.
Okay. So it's going to come soon. Let's put it this way. Thanks, Dalton.
Sure.
Can the same container be mounted by multiple users on different nodes? Yes. You need to set the ACL accordingly. Obviously, each user need to have access to the ACL, and then once the ACL are properly set up, you can mount them on from different nodes. Different nodes for sure. The same user on different node, obviously, yes. But for different user, you need to play with the access control list. It reminds me I didn't give any example in there on how to manipulate ACL, and I should definitely, and I will take that at an AR to give more example on how to add new ACL. So if you want to rename a container as well, you can change the name of a container and change the name of a pool, but the pool is only can only be done by the administrator. And you do DAOS const set prop. Basically, you change the label property, right, from to new count. And then when you list, you see it under new count. And then you can destroy a container. So destroy is asynchronous. It's going to return immediately, and DAOS in the background will clean up the space, right? So it goes very fast, and you can destroy this way a billion file, right? There is an option, I think, -F. By default, we if you want to destroy a container, that is, you have to pass -F if it is not empty, right? Just to make sure you don't inadvertently delete a very important data set, right? Object interface, I will go quickly on this because this is probably too low level. And so, as I explained, we build this POSIX interface on top of the key value store. But in practice, at the lowest level, over the wire, what goes over the wire between the client and the server, this is this, right? We do key value store update, array update. This is the protocol between the libDAOS and the storage node. We build POSIX, all abstraction, everything on top of that as a libraries, right? Which means also that there will be a possibility in the future, if any of you want to integrate further with DAOS, that's possible, right? And our baseline key value store object layer has a lot of capabilities. It doesn't suffer from a lot of limitation that POSIX has. There is no object create, destroy, no size that is maintained. Many attributes that are mostly useless at the POSIX level are not maintained by the baseline key value store. We implement it inside the parallel file system built on top of it. But if those attributes are not useful to you, right, and then we won't maintain them and you will get better performance, right? That's the idea. And it will obviously accelerate the time to first byte significantly. A few examples, we'll go quickly also on this. You can run this DAOS file system scan on your container that you have created. It will give you some information about your POSIX container, like how many files you have, how many directories, symlinks, the depth, the average file size, and so on. So that's just a way to get some metadata about your namespace without necessarily mounting it and scanning it yourself, right? This tool for now is single process, so if your dataset is big, it might take some time. So be careful with it, but that's still very handy. And this one is more about, I have a file, and it's more advanced use cases, right? I have a file, I have 1024 server. I would like to know where this file is located, right? Normally, you should not care, right? It's magic. It's stored somewhere, and when you read it back, it comes back. But there might be cases where you want to know more when, I don't know, some failure happens, whether some file got impacted. You can retrieve the object ID associated with a specific file, right? And then query this object, and it will tell you on what rank this node is located, right? But not to be used most of the time. So data protection, just want to mention, so we do data protection over the network, right? So we want to, data protection is enabled by default. We support a redundancy factor of 2, right? So we use erasure code something plus 2, right? And the widest erasure code that is configured on Aurora today is 16 plus 2. So it means that when you will write something very large, it's going to be distributed across 18 servers, right? Like a chunk, a 1 megabyte chunk or 2 megabyte chunk will be distributed across 18 servers. So 2 servers will be used for parity, a 16 server for the data, right? They will get each of them 128K of data. This is from a high level what is how data is distributed. And you will see if you do write something small, we might not be able to erasure code it because you need enough data to calculate the parity. So in this case, we replicate it. We replicate it over the server. And then as you write more and more and more, the server accumulates enough data to turn replication into erasure code. And this process happens in the background through a process called aggregation, right? But it explains why maybe sometimes when you do large write, you will see better bandwidth than small write, because replication as more overhead than Erasure code, right? But at the end of the day, even if it is replicated, when there is enough data on the server side, all the server will talk to each other to turn it into Erasure code that would be more space efficient, right? So if you monitor the space, for instance, with DAOS pull query, you might see some peak or some spike where the space usage goes up, and then you do nothing. You just wait and look at it and monitor, and then the space will go down, right? That's expected. It's just that you didn't provide enough large IO for DAOs to Erasure code it, so it's replicated. And then as the system become quiescent and enough data were written, we will turn replication into Erasure code, right? And the space will go down because, as I said, it's more space efficient. Just something to know. It's expected. It's not a bug. So the software stack I mentioned, we have this libDAOS library, right, which provide the baseline key value store. And we use this key value store to implement files and directory. I mentioned before, we have implemented a parallel file system on top of it, and just as a library, and this is what is libdfs, right? libDAOS file system is built on top of libDAOS and basically provide files abstraction and directory abstraction, right, on top of the key value store. And then you will see later how you can integrate this libdfs with your app, right? You can use it with Fuse, but there are other ways for your application to eventually write through libdfs. And we will see more into the next section that Mohamed will lead. But we have a bigger ecosystem here, right? We have S3 that is available. We have a way to export as a block device on top of DAOS. We have Hadoop connector. We have MPI-IO that Mohamed will mention as well. We'll talk about PyTorch. We have TensorFlow that we don't advertise that much lately because it seems to be getting less love from the community, but it's still available. And I will explain more about the PyDAO stuff. And there are examples, maybe not relevant to you in the industry, like Segway from oil and gas, FDB from ECMWF for in Europe, UK, root and format and data acquisition from CERN, where they build directly their data model on top of libDAOS, right? And to get the maximum performance and the maximum capability, and not using the POSIX POSIX interface. So how do I get my data in? So today you can do it in a simple way on the UAN by just doing the DAOS FS copy, where you can mount, diffuse, and copy, as I said. But there is a more efficient way with DAOS FS copy when you provide the source where in the local file system, the directory, and then the destination where you want to copy it, right? It's DAOS, name of the container, name of the pool, sorry, and name of the container, and then it will do a copy. But this is single process on the UAN. We are working with the ALCF administrator to implement the 100 gateway nodes. I don't know whether it's going to be the 100 of them, but there are gateway nodes on the system that will be a specific PBS queue where you will be able to use MPI file utils, as we mentioned, and queue jobs that will move data very quickly in parallel using DCP and other tools available in MPI file utils between. Thanks. So data mover. So we have the DAOS FS copy that is available. It's single process, so you can just copy on any on the UAN, right? DAOS FS copy the source of the directory on the local file system and the destination. So this is the pool name and the container name. It's a handy way to copy. You can also mount, diffuse, and copy between, but I think DAOS FS is probably more efficient. And we are working with the ALCF administrator to implement the gateway node. There are 100 gateway nodes on the system. I don't know whether we'll use the 100, but we'll see what will happen at the end. But that will provide a specific queue on PBS Pro to be able to launch job to do fast data movement between file system available at ALCF like Flare, Luster, and copy the data to DAOS and also move data back from DAOS to external storage system, right? This will be using MPI file utils and will be able to split large directory across all the data mover and also large files and so on. So that's going to be a very efficient way. So once it's available, we will definitely provide more instructions. DAOS fault handling, so quickly on this, I mean, as I understood, DAOS is fault tolerant, distribute data across multiple nodes, is intelligent storage and rebuild automatically when some failure happens. But maybe as a user, one thing you can monitor is that, so everything is online. So the system, even when there's a fault, should always be available, right? But there might be a little bit of performance impact sometimes when rebuild run. And if you see something that is maybe slower than expected, some of those information are accessible to you, right? When you do the DAOS pull query, you have this pull else information. So you have the state here, right? In the previous state, we had rebuild done, which means that no rebuild was happening and everything was operating properly. And rebuild busy means that there was some fault identified inside the storage system, and DAOS is in the process of recovering from it. It involves data movement between the storage node, right? This is online. The data should still be accessible. You can continue to operate normally, but you might see sometimes some performance impact, and that's something interesting to notice, right? And normally the performance should be very minimal, but still something to look at if you run into any issues, and to report maybe when you file a ticket. Last one, I wanted to mention a little bit about the client. So on every compute node, there is an agent running, which is basically the client part of DAOS, the daemon running on the DAOS daemon running on the compute node. We call the control plane. And actually, this control plane is in charge of wiring up, connecting libDAOS to the storage node, authenticating the application, tracking whether the process dies, and so on, and reclaiming resources when it dies. But one thing to notice here as well is that libDAOS can today only connect to one network interface. So when you use libDAOS through different way inside your application, there is a sort of round robin happening to be able to use all the network interface. And basically this round robin is done per socket, right? So on Aurora, we have 2 sockets on the compute node, and we have 4 interfaces per socket, right? So the task 0 will be allocated the first network interface, task 1 the second, the 2 the third, task 3 the fourth, and then we go on, we run robin. Task 4 that will be bind to the CPU socket will go back to the first interface, and we run robin this way, right? And then any process scheduled on the other socket bind to the other socket. When it starts, it will be allocated network interfaces on the second socket, right? So for instance, if you have 8 processes, if you run them on CPU socket 0, you bind them to CPU socket 0, you will most likely use only 4 interfaces, right? And each process will use 2 interfaces. But on the other, if you take those same 8 processes and you spread them across the 2 CPU socket, 4 plus 4, then you will be using all the network interfaces and potentially getting more bandwidth from the compute node, right? Something to keep in mind that it's the interfaces we use on the compute node is sensitive to the CPU you bind to, right? And we do this round robin all the time for different processes. And it was the last slide of my presentation. Any question before we move on to the next one?
Johann, can I mention something?
Sure.
Yeah, just to repeat this particular graph. So for performance, you definitely, because many users might be choosing to run with like only a few processes per node, you know, a lot of people use, let's say 12. You want to make sure that some processes are on socket 0 and socket 1, and that you're trying to do IO from all of your processes to use all the NICs. I believe our default aggregators is set to 8, so it will try to use, if you use MPIO, it'll try to use all the NICs, but that's one area where if you're running a small number of nodes and your performance is low, it might be because we're not saturating the number of NICs on a per client node basis.
Yep, makes sense.
Yeah, just quick question. Can you say something about the array data types, as opposed to like the key value?
Yeah, so the array data type is basically so you have a C library that you can use, and basically it you define an array with a cell size, right? With the array, the size. And when you use file and direct file, for instance, we have a 1 byte array, but actually you can specify a specific array size, and then you can just do update across a specific range of indexes, right? It's a one-dimensional array. And we have the API available. I can point it at you. And Mohamed wrote it, so Mohamed might be a better candidate to answer your questions.
Okay, and so that's probably good if I have just some like very large binary blob of data I would like to write somewhere.
Yep.
Yeah. Okay.